Given y equals f of x equals the sine of x, quick, graph y equals f at the opposite of x, which equals sine at the opposite of x by hand, two different ways, and then decide if this function is even, odd, or neither. This is part of the family of functions series. You will need paper and straight edge. We suggest you create grids similar to the ones at the right as needed, and of course press pause as needed anytime during the video. The first way is quadrant by quadrant. So if x is in quadrant 1, that is x is between 0 and pi over 2, as shown here. The opposite of x is in quadrant 4, between 0 and negative pi over 2, as shown here. In quadrant 1, the sign of x is positive, but in quadrant 4, the sign of the opposite x is the same value, but negative, which means that they are opposites. So in quadrant 1, the sign of the opposite of x is equal to the opposite of the sign of x. If x is in quadrant 4, that is, x is between 3 pi over 2 and 2 pi, then the opposite of x is in quadrant 1, where x is between negative 2 pi and negative 3 pi over 2. And just as we said before, in quadrant 4, the sign of x is negative. In quadrant 1, the sign of its opposite is positive. So they are opposites. And so in quadrant 4, the sign of the opposite of x equals the opposite of the sign of x. In quadrant 2, when x is between pi over 2 and pi, its opposite will be in quadrant 3 between negative pi and negative pi over 2. In quadrant 2, the sign of x is positive. But in quadrant 3, the sign of its opposite then is negative. They're the same value, but opposites in sign. So in quadrant 2, also, the sign of the opposite of x is the opposite of the sign of x. And finally, in quadrant 3, when x is between pi and 3 pi over 2, its opposite is between negative 3 pi over 2 and negative pi, which is in the second quadrant. And as we said before, in quadrant 3, the sign of x is negative. In quadrant 2, the sign of the opposite x is positive. They're equal in value, but opposites in sign. So in quadrant 3, the sign of the opposite of x equals the opposite of the sign of x. Therefore, in all four quadrants, the sign of the opposite of a number is equal to the opposite of the sign of the number, which is the definition of an odd function. So the sign is an odd function. The graph of the sign of the opposite of x is identical to the graph of y equals the opposite of the sign of x, as we'll show here. Here's the sign of the opposite of x. Here's the opposite of the sign of x. And as you can see, they are exactly the same. They are identical. That is an identity. Second way to show this is using a table. So we'll use our axes values for the sign of x and ask you to pause to complete the table. And those are the values there. We need to create a second table for the sign of the opposite of x. We're going to keep the x values the same, but the rules are we need to take the opposite of what x is, then take its sign, and then fill those values in the table. So go ahead and pause to do that. So the sign of the opposite of 0 is the same as the sign of 0, which is 0. The origin stays there. However, the opposite of pi over 2 is negative pi over 2, and the sign of negative pi over 2 is exactly the same as the sign of positive 3 pi over 2. They land in the same spot on the unit circle, and they are a period 2 pi apart. So that's going to be equal to negative 1. So the sign of the opposite of pi over 2 is negative 1. But notice we're plotting pi over 2 comma negative 1. This is our x value. We take its opposite to get the y value. The sign of the opposite of pi is the same as the sign of pi. Again, they land in the same spot. They are a period apart. The sign of pi is 0, so pi 0 will be our next point. The sign of the opposite of 3 pi over 2, negative 3 pi over 2, is the same as the sign of pi over 2. Again, they are a period apart, and that's 1. And the sine of negative 2 pi is the same as the sine of 0. Again, they're a period apart, and that's 0. So 2 pi comma 0. We'll join the points as a sine curve. It will be a smile and then a frown. That's one graph of the period. Let's graph another to the left by going back a period, 2 pi, from each point, especially the points of interest. And again, we get a concave up followed by a concave down. Just the inverse of what we did for the sine function, kind of the reverse of that. And comparing that to the opposite of sine x, you can see that the sine of the opposite of x and the opposite of the sine of x are equal all the time. The sine is definitely an odd function. Pause is needed.